Hi students, welcome back to ChemOrgChem. So in this JEE Chemistry Insight series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the problem from JEE Main 2025. As per this question, propinaldehyde react with excess of formaldehyde in the presence of alkali under reflux which produce a product. So here there are four options are given. Let's solve together which one is the correct option for this question. So first write it down. Our question, propinaldehyde react with excess of formaldehyde alkali under reflux. So once you see this reaction condition, most of them get an idea about this reaction. So this reaction is Cross-Aldol condensation reaction. So as per Cross-Aldol condensation reaction, so we need alpha carbon contains proton that initially interact with base which produce corresponding intermediate. That intermediate react with another aldehyde or ketone, resulting that produce alpha beta unsaturated alkene as a final product. So as per that context, so here most of them expect to get this corresponding alpha beta unsaturated alkene as a final product. However, in this reaction doesn't produce this corresponding product. So let's see why this product not formed instead of some other products formed in this reaction. Let's see why this product is not formed in this reaction. So first you take the propinaldehyde. So this is the carbonyl group. So near carbon is alpha carbon. So this alpha carbon contains two hydrogen atoms. So when propinaldehyde interact with base, so here alkali, so alkali means that any kind of bases such as sodium hydroxide or potassium hydroxide or calcium hydroxide. So now this hydroxide ion now abstract the proton from this alpha carbon, so resulting that produce water as a byproduct along with this intermediate carbanion. So now this carbanion species react with formaldehyde. So here formaldehyde act as a electrophile. In case of this carbanion act as a nucleophile. So now this negative charge attack this carbon atom. So resulting that this pi bonded electron move towards oxygen atom which produce this corresponding intermediate. Now this intermediate quickly takes the proton from water molecule. So here you see O negative charge now abstract the proton from water molecule. So resulting that kick off hydroxide ion to produce this corresponding intermediate. Now closely look this intermediate. So here you see carbonyl carbon. So this carbon is alpha carbon. So this alpha carbon contains one more alpha hydrogen atom. So therefore the sequence of reaction going to takes place one more time. So now base again abstract this alpha carbon containing protons. So resulting that water molecule is eliminated to produce this corresponding carbanion. Now this carbanion species react with formaldehyde. Since here you see in our question they given excess of formaldehyde. So now this negative charge attack this carbonyl carbon. So resulting that this pi bonded electron move towards the oxygen atom which produce this corresponding intermediate. Now this intermediate readily takes the proton from water, so resulting that kick off hydroxide ion and produce this corresponding intermediate. So the whole sequence of reaction is known as Cross-Aldol condensation reaction. You just remember, as per cross-aldol condensation reaction, we should get alpha beta unsaturated alkene. So, however, in this reaction produce only this aldehyde intermediate. Why alpha beta unsaturated alkene is not observed in this case? And another important point, in cross-aldol condensation reaction usually produce mixture of products. So however, here we are getting only this intermediate aldehyde as a final product. Why this happened here? The reason is formaldehyde. Since formaldehyde is one of the mostly reactive aldehyde. So now compare to this propanaldehyde. So in cross-aldol condensation reaction, so this carbon ion can react with another propanaldehyde. However, now you compare with reactivity against propanaldehyde and formaldehyde. So formaldehyde reactivity is higher, therefore, so this carbon ion prefer to attack formaldehyde rather than this propanaldehyde. So for that reason, we never observed in this case mixture of products. So next come to the why we are not observed alpha beta unsaturated alkene. So again, because of the reactivity of formaldehyde, apart from that, now you see this intermediate species. So this carbon is alpha carbon, contains proton. So now you see this particular carbon is more acidic since this carbon attached with CH2OH group as well as aldehyde group. So therefore this intermediate also highly reactive. So therefore here hydroxide ion readily takes the proton which produces this corresponding carbon ion which then quickly react with more reactive formaldehyde. So for that reason, here we are not observed alpha beta unsaturated alkene as a final product, as well as here we are not observed any mixture of product. So however, this is not our final product. So this is the intermediate of this reaction. So let's moving on. So this is our intermediate aldehyde. So I said this reaction not yet finished. So now you see formaldehyde. Just now I said, so formaldehyde is one of the highly reactive aldehyde. So therefore, this formaldehyde can quickly react with hydroxide base itself. So as per this hydroxide ion attack this carbon atom. So resulting that this pi-bonded electron move towards the oxygen atom, which produce this corresponding intermediate. Now closely look this intermediate. So this oxygen negative charge move towards this carbon atom. So resulting that this hydrogen atom coming with electron that attacks this intermediate aldehyde. So now this pi bonded electron move towards the oxygen atom which produce this corresponding intermediate. So along with formic acid byproduct, so this formic acid byproduct now interact with hydroxide ion base which readily takes this proton which produce this formate ion as well as water as a byproducts. So now this intermediate species now takes the proton from water, so resulting that kick off hydroxide ion base which produce this methanol as a final product for this reaction. So this reaction is known as Cannizzaro reaction. As per Cannizzaro reaction, the two aldehyde should not have any alpha hydrogen atoms in alpha carbon. So in these two aldehydes react under basic condition. So one of the aldehyde is reduced and another aldehyde is oxidized under this reaction. So those reaction is known as Cannizzaro reaction. So now you come to our reaction. So here you see formaldehyde. So doesn't have any alpha hydrogen atom. In case of this intermediate aldehyde has alpha carbon but doesn't have alpha protons. So therefore here formaldehyde is oxidized in case of this intermediate aldehyde is reduced. So which produce this material as a final product. So therefore in one reaction combines with Cross-Aldol condensation reaction and Cannizzaro reaction, that particular reactions known as Tollens condensation reaction. So therefore this reaction is known as Tollens condensation reaction. So as per Tollens condensation reaction, propanaldehyde react with excess of formaldehyde in the presence of base under reflex condition, which produce methanol as a final product for this reaction. So here you should not confuse with Tollens reagent, since Tollens reagent and Tollens condensation reaction both are two different concepts. So let's moving to our question. So as per our discussion, among the four answer, the correct answer for this question is option 1. That's it for today's problem. I hope this video has helped you to understand Tollens condensation reaction. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.